up, everybody? It's Coach Nick Money, and today we've got a treat for you indelibles. We have the team from 3DX Industries, ticker symbol DDDX. We've had interviews with 3DX Industries before, very transparent, pink current OTC company. And today we actually have the CEO and president, Roger Janssen, and the general manager, Adam Bierschank. How did I do, guys? Pretty good, huh?
Great, Nick. Great,
Welcome.
Nick. Thank you.
Welcome, and thank you for joining us, gentlemen. So I'm going to start off with a couple of questions, if that's okay with you.
Yeah.
All right.
Good.
So can you tell us a little bit about what the company does?
Yeah. 3DX Industries is a manufacturer. We manufacture parts from many different industries, from marine, medical, military, aviation. We have over 40 years of combined or total experience from the company's inception. 3DX, let me make sure that's correct. It's been around since 2008. I sold a private company to 3DX, and I've been in the manufacturing my whole life. We manufacture parts from Subtractive and Additive, and we support many industries, and it's a process of making machine parts and printed parts.
Well, that's very interesting. Can you share with the community what the difference is between additive and subtractive manufacturing?
Yeah, Nick, the difference with traditional subtractive manufacturing since the great industrial revolution in the mid-1850s, when people were able to take large blocks of material, steel at the time, and you carve that into a part. All of your materials, everything that surrounded the you look around at was touched by somebody in a machine shop, whether it was the tooling to make it, that was carved out of a large block of steel that's poured in a big mill. Somewhere, everything was touched by a machine shop. So manufacturing is a big deal for us and everyone. And traditionally, it's always done on manual machines or with computer-driven CNC rotary cutting machines. I have an example I'll get to here in a second. And then there's the additive process. And the difference is in additive, you start with a powder and you only use the material that you actually need to make the part. Now in subtractive, you'll see a large block of material here in a second, and then a smaller part, which is actually a tool steel. It's a very expensive material, but we cut over half of it away and threw it away. For additive, we use exactly what we need, and the material we don't use that's used in the process is recycled into the next batch. So it's a manufacturing friendly material. It's a green process. And it's also much more cost effective. Some of these materials are very expensive. So when you're making that part, if it's a complex part, expensive to machine, we also have the opportunity to make those types of parts because we're using the technology based in the machine that's able to print the complex geometries. Now that being said, this is a part here, and this is I had a sample part here, but it was sitting on the cart just before the interview here, and the cart destroyed and fell on the floor. And this is a cutting tool that we use. This is a large cutting tool that would be used for a subtractive process. And the interesting thing about that part that you'll notice, we're working with one of our customers that does work for the U.S. Navy. And these parts, they're being looked at by the Navy to be additive manufacturing. They've been done this way for 80 years. And they're looking at converting those processes over. And that's that one part that just hit the floor and broke our cart. So
sounds like it's pretty heavy.
Yeah, it was like several hundred pounds. I think the car was rated for, but who knows what happens.
So basically, the additive manufacturing is the 3D portion of it, and you do both 3D as well as traditional. Is that correct?
Absolutely. And additive manufacturing, it's a fantastic technology. There's a couple of different ways it's done. Mm-hmm. You always need to have a traditional manufacturing process involved in almost all of our additive manufacturing parts. So we can print the part is probably 90% complete most of the time, and then there's a couple processes that we go back to the subtractive side and finish up for fine, super close tolerances or slip fit bores or parts that need a certain characteristic done perfectly.
So my understanding is that you have 3 different types of 3D metal printing. There's the DMLS, which is direct metal laser sintering. I hope I pronounced that correctly. Binder jet additive, and wire laser metal 3D printing. Can you tell us a little bit about each one of them? Let's start with the direct metal laser sintering.
Okay, Nick, and just for clarity, those are the three main processes of metal printing, and the one we use is binder jet, but I'll go into those as we go through that.
Okay.
So direct laser metal sintering is a process where you lay out a layer of powder, very thin metal powder, usually like in a 30 micron size. It's laid very thin, like the thickness of your hair. Then you have a laser that will come down and it'll weld that layer together, layer by layer. So as your powder bed drops, the laser, each layer, it builds that part in that powder. And now binder jet is a little different process. You use the same type of material, the 30 micron stainless steel. We use a J10. And that process is put together at a layer at about 3,000 thick. And then it's binded together with we have a precision print head that has 1,100 precision print modules. And it glues that material together with a special bonding agent. So we accurately glue that metal together, and that process, then it comes out and it goes into a sintering furnace, and that metal at about 2,048 degrees, after about an 18-hour process, the metal becomes, for lack of a better word, mushy, and it glues itself together. Then the furnace drops it down in a heat treat cycle, and it comes out a solid piece of metal. So now the direct laser metal sintering welds it together instantly. We glue it together and run it through a sintering process. And now on the wire laser printing, that's an interesting technology that's catching on. By the way, the binder jet is our process here. We have two of these binder jet machines.
Okay.
The wire printing is where Adam, could you explain that a little bit? I think you're a little more familiar with that.
Yeah. So the wire, or the directed energy deposition machines, they basically have a laser that has and also a wire that's coming across. And as the wire comes across, the laser's melting it. Also, it does spray powder. It can spray powder at the same time. So it just builds up layer by layer, kind of like your regular plastic FDM printer that most people are familiar with. So except it's a laser and it's metal.
So there's a lot of different ways to basically do this, but you've decided to choose the binder jet additive as your niche. Is that pretty accurate?
That was the one that started this all for us. We're looking at the other technologies as we analyze our customer base and look at the projects going forward, and eventually we will be involved in all the metal printing processes.
So you're going to do every single one of them. Okay.
Well, there's a lot of crazy guys inventing stuff on the outer edge that who knows what it's doing, but the main ones we will definitely be involved in.
Oh, okay. Adam, it looks like you wanted to say something.
Yeah, I think that the binder jet is.
Gentlemen, I'm just going to ask you to speak a little louder because I'm having a hard time hearing you.
Okay.
And something just went on with the lighting, so I'm not sure what that was about.
I'm not sure. The binder jet is probably the closest to like a production printing technology. So the throughput and the price point is the most competitive at this point. So if we want to make 10,000 of the same little part, binder jet is going to give the most cost-effective price, and that's we're looking to become a production 3D print shop. There's other technologies might be good for certain things, but it's different kind of RFQs that we would be seeing on that. So we're going to stick with this because there's so much we can do. And then, the different powders that you put in it are going to change. In the future, the most advanced materials of the future will only be able to be 3D printed. So, they're composite materials. It's not like steel. It's steel and this, or steel and that, or different materials. So those materials will be designed to be 3D printed, and the only way you'll be able to do it is a printing process like this. So we're sticking with it.
So it's basically the present and the future. It's now and the future.
Yeah. Well, yeah, we've been in the from the beginning of these machines. Roger's been in it, and they're just catching on to like where these big companies are putting out these RFQs for additive parts. So it's catching on in the world, and we're at the front of that. So
these are some of the reasons why the companies are turning to additive manufacturing. It's more efficient. It's easier to do. It's cheaper. It's cleaner. It's greener. Am I missing something?
Yeah. Well, and there's parts that you just can't make any other way. So, when you've probably all seen like the generative design stuff where things get designed by a computer. Well, 3D printing will be the only way those parts will be made. Just
I love it. Very
Yeah.
innovative, and it makes so much sense.
And it's also
Let me ask you this. There's technology. I'm not sure if it's technology or not, but J10, it's one of the materials that 3DX Industries co-developed with McLean Fogg. Can you tell us a little bit about it?
Yeah, early on in our R&D phase of our first printer that we picked up, I think in 2012, we got hooked up with a company called NanoSteel that has been bought a couple times. It's now owned by McLean Fogg, which is one of the largest fastener manufacturers in the world. And we developed a material that I was going to go through some of the just on the technical side, if there's any technical people watching this. It's a stainless steel based material that has a very strong characteristics. It machines good. It has long wear characteristics. We originally looked at it. We were designing and printing downhole tools for the oil industry. And what they found using our combination of material, the McLean Fogg, along with our bronze infiltration process, those parts were lasting 4 to 5 times longer because of the composition of the material. Like you have, just as an example, the J10 has the chemical composition is iron, chromium, nickel, silicon, boron, carbon, molybdenum, manganese, and tungsten. And when a company blends those materials for the requirements we need, we can develop, like Adam was saying earlier, a specific material. Now the young engineers are looking at this going, now I'm not confined to the old way of just being able to say I have to use 304 stainless or 4140 steel. They can literally use their engineering skills to design a part, and you design the metal along with it. And that's the only way that you can do it, is be able to 3D metal print that. Now that J10, they helped us design that, and they are actively printing themselves, but that is like the material that we developed with them, and it's a great material. We print almost all of our stuff on that.
So you've got a lot of stuff going on. Can you describe 3DX Industries' strategy of advanced manufacturing cells and explain why now is an opportune time for this adoption?
Yeah, and our roll-up plan here at 3DX is to introduce additive manufacturing modular components as we acquire other manufacturing companies and introduce the process of converting their customers over. It's called the DFAM on their parts, Design for Additive Manufacturing. And it's going to allow them to jump into this industry with somebody that's going to support them. And a lot of people are just selling the machines. Like when we bought our machine, the truck showed up, they threw it off, said, good luck. So we've gone through that process. We've spent years and years figuring that out. And we have it figured out. We're very good at it. And we're going to implement these modular additive and and there'll be some robotics involved. We're going to use all the technology that's going to be based around additive as we work with these manufacturers that we're rolling up.
So let me ask you this. There's always legislation that the U.S. government is coming out with. Something that comes to mind is the American Forward Innovation Act. What kind of involvement do you have, or may you have, with that particular act?
Well, that's something that recently came down from the Biden administration, and they're basically celebrating the launch of AM Forward. And they called on Congress to pass a bipartisan innovation act. And maybe you want to go into that a little bit, Adam.
Yeah, I was just as these larger companies are developing their different parts and processes. Basically, they'll send out RFQs to us. What this AM Forward is to encourage them to create more prints that spec additive manufacturing processes, basically. So every print has a spec on it. This one's always made with 316 stainless. Well, this is to get them to spec an additive manufacturing process in there that is equivalent. So it just means that GE, Ford, all these big companies, they're going to be putting out more RFQs to additive manufacturing companies like us. So
fantastic.
In a way to help stimulate the economy, they realize that technology is the way to do it. I think this act has a $200 billion tag on it.
Mhm.
And with electric vehicle production, there's a huge opportunity in additive for everybody.
And you're right there ready for it. I love it. That's fantastic. So if the community wanted to learn a little bit more about additive manufacturing, 3D printing, do you have any resources that they can go and check out?
Yeah, I think a great place, Nick, is I'm going to show a cover of the magazine here as I put it to the screen, and we can maybe put a bit of it on there.
Yep. Can you pull it back and up a little bit?
There you go.
Yep. Perfect.
Modern Manufacturing Magazine is the leader on the planet as far as keeping track of what's going on in the manufacturing world. They also own Additive Manufacturing Magazine, but if you go to their website, they have an additive manufacturing area, and they can keep you as up to date as we can be on that. And it's a great resource for learning more.
Fantastic, gentlemen. So there you have it, peeps. We have the executives from 3DX Industries, ticker symbol DDDX, Pink Current. Full disclosure, they're constantly putting content out on Twitter. They're constantly having interviews with many influencers besides myself. Love the company. Thank you so much, gentlemen. Appreciate you coming on board and speaking about what you're doing. Thank you.
Thanks, Nick.
Yeah, thanks.
Bye-bye, everyone.
Anytime.
Take care.